Hi there, and welcome to another Haltech debate. Today's topic, the best and worst tuning practices. Now, today's panel are pretty amazing. Between you guys, I've been tuning for a little bit. Between the three of us, about 50 years of tuning experience. Adam, we'll start with you, mate. I've been here for nearly 20 years, but I took your job at Haltech. That means that Jem must have been going for a fair while.
Yeah, I started working at Haltech back in 99, so early 99 I started working there. And before I started at Haltech, I was already using Haltech products, so doing ECU installations from home, at friends' houses, road tunes, tuning on the freeway, that kind of thing.
You had an 86, I had a Datsun 1600, the Datsun was always faster, and then after that, what?
No way. I can't remember the time the Datsun beat the old Sprinter.
You know what, I was going to say this till later, but the absolute reality is that the Datsuns always chase the Corolla every single time, and even though the numbers have gotten huge now, huge horsepower, huge times, I never got the Corolla, not once, and we're on record now, so that is the truth. To get my Datsun going, back in the day, I needed you to come and start it for me, and that was on a Haltech E6K, I think.
Yeah, E6K.
So that's probably about sort of how far we've come from. And moving on to Andy, some of you might recognise Andy from a whole bunch of different videos. Andy Wyatt was from Adaptronic, still is from Adaptronic, but he's also the head engineer at Haltech now as well. Andy, tell me how yours started. The Adaptronic story is also really interesting.
Yeah, so I've always liked electronics in cars since I was little. And in 99, I bought my first fuel-injected turbocharged car to get over a go, which didn't really work. But anyway.
I'll stop you there just quickly. What type of car was it?
The N12 Nissan Exa Turbo.
Right.
If you remember those.
1.5 turbocharged, cute little thing.
Yeah, pop-up headlights, rear seat that you can't really do anything with, 1.5 litre, non-intercooled, compression ratio of 7:1.
So anyway, where did the Exa drive you? What happened from there?
Yeah, so I bought the car at night time, which is a mistake. I'm never going to do that again. It's going through lots of fuel, and I got the injectors checked, and I swapped in a known good airflow meter, and eventually the last component that I couldn't find a good one to swap with was the ECU. So at that time I was a student, so I had no money and lots of time, and I always wanted to do electronics on a car, so I thought, well, now's my chance. So I built my first ECU out of old computer parts, because my father used to repair computers in the days when you repaired computers instead of throwing them out and buying new ones. And that's sort of where it sort of started, and eventually then I started up Adaptronic and did that, and then now I'm here with Haltech doing more of what I like, which is the engineering stuff, and I'm loving it.
In the same sort of group, my first car adventure or turbo experience was a Mitsubishi Cordia turbo.
Oh, yeah.
Yeah. 1.8 single cam turbo. The multi-ported style injector, so two injectors in the throttle body.
Oh, that's right, yeah, throttle injection, yeah. So the Exa was fully sequential from factory in 83, so it's pretty advanced stuff.
Adam, first turbo car?
Yeah, I was 14 when I bought my first car. That was an old Toyota T18, and
the blue one.
It was even before that. Yeah, it was actually red when I bought it. I painted it yellow because I wanted to get noticed. Big mistake, because I had bees coming to me every time I pulled up at the lights. But I ended up putting a 3T GTE engine into that, which was a 1.8 twin cam, twin spark engine. I'm sure the Puerto Ricans are familiar with that one, although they like their single cams. But
well, that engine is still relative today. Ours probably done and dusted, I think. So I suppose that there really is the passion behind it, I suppose, is the first thing that you actually need. You can't just crack open a business and just start tuning cars or start making ECUs if you're not passionate about it, because we know in this industry that it does take a lot of time to learn, and you can't just wake up one morning and just... There really is no sort of specific trade for what we do as tuners. First thing I want to talk about are the worst tuning practices that you guys have encountered in your time in the industry. Andy, we'll start with you. Mate, business-wise or the actual nitty-gritty of tuning the engine, let us know, what are some of the worst things that you've seen in the industry and things that we should probably try and avoid?
The worst thing, and I don't know if it can be avoided, you probably have to live through it to be able to avoid it, but where I think a lot of tuners start off is they'll start off doing their own car, friends' cars, road tuning, that sort of thing. Then they can start to hire a dyno, and then when they actually get their own dynos, when they actually start really learning them, because you can spend enough time on the car to learn it. But what you find is that with each new car you do, each new engine, ECU combination and things like that, you're learning as you go because you haven't done it yet. And it takes a lot of time to actually become proficient in any of these disciplines. And what a lot of people do, especially when they've got a dyno and they've got dyno repayments to make and they're trying to run a workshop at the same time and they've got the financial pressure of that, is they'll take on any job that comes to them. And in the early days, you kind of have to do that, I think, because you need to. But I think it's really bad if people continue to do that forever. I think it's a lot better when shops can start to specialise in particular engine things that they know really well, or ECUs that they know really well, or some intersection of both of them. For two reasons. First of all, you can get really good at them, which means that you can give the customer a better result and you can spend less time doing it. If you've got to learn on every car, then you're either charging the customer for it, which isn't going to work for you long term, or you're paying for that learning time yourself instead of charging out for other jobs, which also isn't going to work for you as a business. So, and the other benefit of that is that then you get the marketing benefit as well. It's, I've got a Nissan with a Haltech, I'm going to go to Adam, as an example.
I agree 100% with everything Andy said. It sounded like I was going down memory lane there. Taking on any car, any inquiry that comes through, you're so keen, you've just got this dyno, you've got overheads, you want to learn, you want to be the best. So you take in any job that comes, you generally underquote yourself or undercharge. You spend twice as long because you haven't done this combination before and you need to learn some new things and gain some experience.
I tend to agree that I think that we're probably all really lucky that we did our, call it your apprenticeship, so more of a self-imposed apprenticeship, because in our industry, there's an auto electrical apprenticeship, there's a mechanical apprenticeship. Both of those are super valuable to then become a tuner, but even once you've done either of those things, like I've been here for so long and experienced so many things through so many workshops and I still claim that I'm doing my apprenticeship because every day I learn something, and every single day I think, how have I gone so long without knowing that is actually possible? That's incredible. Yeah. I remember you doing something with your own car that was pretty funny.
Right, so this is my A86 Toyota Sprinter, and that had a 4AG ZE engine, 16 valve big port, with all the supercharger gear deleted, custom exhaust manifold, GT3082 turbo, rear wheel drive, forward facing intake manifold. What happened there, so this was on another one of our cruises. I noticed my engine losing power throughout the night, and eventually I'm thinking to myself, it's just not pulling as hard as it usually does. And after a few more squirts, it started to get slower and slower and slower until I was at the point where I'm full throttle to do 60 k's an hour. And I thought, okay, there's definitely something not right here. Pulled over, plugged the laptop in, pulled the data log out, checked the logs, had a look, could see all the sensor data. Everything actually looked fine. I came to the conclusion that somehow my ignition timing has retarded. So what I ended up doing was I advanced the timing in the trigger setup, and the rev started to pick up again, and reducing the tooth offset by 2, so adding 30 degrees ignition timing in that engine. The car was running good again, so I thought, okay, something's happened. The crank angle sensor must have slipped a cog or whatever. So let's just cruise it home. So I managed to cruise it home, and then the following Monday came into work, had a look over everything, timed up the engine, and I discovered that my harmonic balancer had turned. Pulled the balancer off to find that the Woodruff key had popped out, and the crank timing sprocket had shifted on the crank, which basically offsetted my ignition timing. So easy fix, put the Woodruff key in, bolted it all back together, beautiful. For while it was there, let's do that fuel system upgrade that I've been wanting to do all this time, so I can shove that extra few pound of boost in it, because after driving the 34 for a while, that 34 pound didn't feel fast anymore in the Sprinter. So I upgraded the fuel system, got it all ready, put it back on the dyno, and like a cowboy in my own car, thinking that my car is so good, I didn't put the timing light on it. Here I am with 30 degrees extra timing in my map, based on the tooth offset that I shifted the weekend before to get home. And what was I on the dyno for? To add some boost. First flick at 34 pound of boost, pushed coolant, and I stopped there and went, that's not supposed to happen. Oops, didn't check the timing. Oops, my tooth offset, fixed the timing, didn't push coolant again until I wound it up to the 40 pound mark where it started to push again. So that's my mistake. That's a mistake. So as a rule, and this is a rule that I always apply, and just on my own car I got complacent, and it's like the one time you slip is the one time you're going to cop it on the chin. Always check base timing.
Really, really good advice, and that's probably where we're going today is the problem. Fix it by double checking that the timing in the computer is the same as what's the timing on the engine. So we're synchronizing the ECU and the engine together to make sure that when the tuner types in their magic 16, 18, 20 degrees at 40 pounds of boost, that's when the spark is actually firing. Mate, I completely get it. One of the things on my list of worst tuning mistakes, which I have to admit, on my CA18 powered Datsun a long time ago, running on petrol as well. At the time there wasn't really much ethanol. Similar story where I'm one step ahead of you where I did check the timing, so that's awesome. So I locked it at 20 degrees of ignition timing just to make sure that when I put my timing on the crankshaft and it said 20, and I thought, that's awesome. Okay, so nothing's moved. And then I closed my laptop and I drove, and then that was it. And about a week later, I was thinking, this just doesn't feel right. This engine, is just not on song. There was something that wasn't right about it because it was locked at 20 degrees of ignition timing. So no matter what RPM, no matter what boost pressure, it just had 20 degrees everywhere. Didn't want that. And it ended up getting a set of rods and pistons, which with my tuning skill at the time and what was available, honestly, it probably improved some parts of the tune, but it definitely did not improve the on-boost area. 100%, it was terrible. Well, while we're still on the topic of some of the worst sort of setup or tuning mistakes, I've got an absolute cracker that I can't claim personally, but was sort of involved in it to go through and do all the diagnosis and actually figure out what was going on. And it's similar to a lock timing situation where what was happening with this car is that it had an ECU installed, everything was there, hit the key, it'd start and run, but you'd move the timing up, you'd move the ignition timing down, you wouldn't really see any difference to the way the engine was running. Move the fueling around, same thing. You wouldn't really see any difference to the engine, which to me, it just made no sense. The ignition had been wired to the injectors and the injectors had been wired to the ignition. So our coil charge time was just our solid injection time. That was it.
So did you tune on the dwell map there?
No. I always think about it because it's so incredible that it actually started and ran not terribly. It burnt a lot of time.
Once I was looking at a car and trying to work out why the ignition timing, the tuner reported that it was drifting. So it'd start off and it'd be locked at the correct time, but it would gradually retard over a period of sort of 20 degrees or so for the first 5 seconds that the engine was running. So it's like it's losing its place or something like that. Lose its place. Anyway, turned out that it was an RB30, which has got the sensor on the camshaft, adjustable cam gear, not tightened up. So it was drifting over time.
Yeah.
Anyways, that
I've experienced that one before.
And just the right tension.
Yeah, to gradually move. And I've also seen another one, which was the car was tuned. The tuner did a good job. He checked the timing and everything. And then went away, came back, it was down on power, reported that the timing had shifted by 20 degrees or something like that. So corrected it, went back out again, came back a few weeks later, same problem again. In this case, it was the end of the camshaft where the drive goes in from the cam angle sensor was chewed out. So it was just friction fitting in there and gradually moving over time.
Another booby trap.
Yep.
I've experienced those as well. Pretty common.
It seems so, like I get it that people sort of look at us, oh, well, the timing's drift. Oh, the ECU's changing it. It's so easy to blame that first before looking for mechanical changes. Now, before we go on to some of the best tuning practices, I thought I might throw it in the middle. Something like, what's the engine that you guys actually like tuning the most? One that turns up, you go, yeah, this is something that's going to make good power, and you just think it's always a great result. Andy, what are you thinking?
I think probably my favourite ones to do is when there's someone that's really passionate about their car, obviously, because that's what we're here for. They've got an NA car, they've put a turbo kit onto it, replace the injectors, because you definitely need to do that, and then tune it. Because normally factory ignition system is up to the job if you're only running low boost, like 7 PSI, something like that. Normally the factory fuel pump's probably alright as well. And normally it goes really, really well, and the guy with the car's got 60% more power, something like that, and it feels a completely different car to drive. And it's still off-beast response is still nice. It's just goes well.
Sort of breathing life back into a customer's like sort of pride and joy that they might have grown out of unless they did something like add more power to it.
I think doubling the power output of any car is always going to put a big smile on the customer's
Yeah.
face. So it's definitely rewarding.
What's your one? What's the one that you like seeing drive through the doors?
Oh, look, probably one of my personal favourites, because it's such a beast, would be the supercharged V8 combo.
Interestingly, that's probably the same answer to my next question, which is, what's the most difficult engine to tune?
Yeah, ditto. It would be. I'd say it was difficult figuring out what those engines are like, and coming up with a combination that is consistent and works. I mean, at the end of the day, we want to be able to turn the key and it starts, idles, drives, hot and cold, and makes power and doesn't blow up.
So tell us what type of engine are you talking about here?
Mainly we see it on the small block Chev with the 671 or 871 supercharged. And we see a few, but not so much these days, the good old Holden 308. They used to get stroked out and 671 on top, but nowadays it's mainly the Chevs. So small block Chevs and the occasional big block Chev comes through. So.
And what makes them, like, what's difficult about it? What's challenging when something like that turns up?
Apart from being intimidated by it, from the tuning side of it, well, we worked out, and we did a lot of development with Paul from ProFlow Performance. He's bought me the most of this combination, and we've figured out together what these engines like. So we've come to the conclusion that having all the injectors up the top, trying to reduce the size of the air or the volume of air going into the hat can improve the drivability. Camshaft choice is actually a big thing. Compression ratio is a big thing. So if you need to get... That's sort of like the fundamentals of tuning one of those things. You need to get your compression and your camshaft right. And then having all the injectors up top, you can have a hard time getting your transient throttle enrichment right. Startup is always a hard thing, especially if they're on E85, because all your fuel's so far away from the intake valves. So you find yourselves doing unusual things with prime tables, transient, like I said. Your coolant enrichment map isn't your typical looking map. And then again, once the thing actually starts and runs and got your transient right, and is for your mapping, you can't target your traditional Lambda 1 or your 14.7 to 1 on cruise. Again, because all your fuel and air, fuel's being sprayed up the top, so the air and fuel doesn't actually distribute equally across all cylinders. So looking at EGTs and reading spark plugs, we've kind of figured out the happy medium for these engines. So instead of your traditional 14.7 on cruise, you might run 13-1 on cruise to help those hotter cylinders or those leaner cylinders still have a good mixture. And then intake temperature is a big problem with these. So generally they don't have intercoolers, and that was our biggest failure or cause of engine failures at the start, was intake temperature going too high from spraying with port injection. So we were seeing, intake temps of 130 degrees plus, which is the full range of the sensors. Air temp sensors coming out melted with melted tips. Air temp sensor stopped working. Oh, wow, pull it out, melted tip. So that's how we slowly, so then we thought, let's put some fuel at the top. And then we come to the conclusion, well, hang on, these carbureted guys seem to be running all right. And they don't have port injection. It's all garden hose up the top, as I like to call it. So since we've done that, that's, and run a richer mixture, that's pretty much the secret to holding these things together.
What about you, Andy? Do you think of any that have just something that it's very complicated to get the thing to just be right?
Yeah, my example is actually at the opposite end of the scale. It's a bit esoteric, but there's this competition called Formula SAE where these university students build a race car capacity limit of 610 cc's. So they use CBR 600 engines, GSXR 600, things like that. Now, the rules say you have to have a restrictor, which is 20 millimeters, I think, and you have to have the throttle before the restrictor, which means that you end up having the throttle, then the restrictor, and then a plenum on this engine which was designed for individual throttle bodies. So because it's a bike engine that revs to the moon, the overlap is so big that at idle you end up with all the exhaust going back. So with individual throttles, it's fine because the throttle restricts the exhaust going back into the intake. But when you've got a common plenum, they just don't work well. So I thought at first maybe it was just my lack of tuning ability, but when you get to the competition and you see that all of them are idling at $2,500 and none of them start nicely and that sort of thing, I found it very, very difficult to get it nice, shall we say. I don't think I succeeded in getting it nice, and I've done a few of them. GSXR, that was the best one actually, CBR, and also some people run the V-twin Aprilia engines as well, and that's even harder when you've got a common plenum because it's odd fire. So the two cylinders fill up different amounts.
My arch nemesis is a huge slipping stall converter where I find myself going around and around in circles trying to get the engine to be making the most power, the most efficient, but when there's a huge stall converter and I can't get to all those sites to actually tune them the way that I want to, I always find that I spend way too much time there, and it frustrates me that I can't get to those particular points. But at the same time, when the thing revs up and it just drives beautifully, there's definitely something in that where you think, that's pretty good that that's something as complicated as that can drive so well, and I think that's probably the reward you get. I've got a list, like a checklist of things that I sort of either have had problems with before or just kind of got in a habit of checking when a car first turns up that you haven't built and you haven't wired, because they're the things that are going to booby-trap you the most often. Starting with a full tank of fuel.
Yeah, I can give you stories about that as well.
I know that I'm definitely guilty of it, of trying to tune a car and you get to a quarter, an eighth, the fuel gauges, wherever, all of a sudden, all of your mixtures are a bit funny and you're starting to add fuel and sure, I tuned that cell before.
Yeah.
Are the battery terminals tight?
Pretty common.
Even though something starts and runs and the starter motor gets enough current to actually get it going, so many times you just twist the terminal off and go, that would have been an ignition problem later. That would have been a something. Fresh set of spark plugs with the right heat range and the right gap.
Yeah.
The ground strap from the battery negative connected to the chassis and connected to the block. Another one that if we're using the chassis as the ground strap from the back of the car to the front of the car, obviously there's exceptions like your stuff where the battery's in the boot factory and it's got like the thick chassis part to go up the front. But if it's a conversion car, it's one of the first things that I'm always looking at, because I'm always thinking, this chassis is not a wire. Checking base fuel pressure and checking the fuel pressure reg's got a vacuum hose on it if it's vacuum referenced before you start tuning it, because probably guilty of this as well, that when you're not vacuum referencing the fuel pressure when you should, and then all of a sudden you're tuning it and your numbers are all going sky high because your fuel...
Like once I've checked base timing, fuel pressure is the next thing. So you always make sure your fuel pressure is right at the beginning of the tune. On our dyno, we've got the mainline all-wheel drive dyno with the fuel flow module. It's amazing what you find when you're using a fuel flow module and how much time you can actually save.
Measuring fuel flow, it makes complete sense, because as well as that, even if you're sort of not aware or whatever the case of the numbers when it started and idling, especially up top, now that cars are making so much power, that not knowing that it's almost out of fuel system and still getting the right mixtures, but knowing that something's going on in the engine is, so having the fuel flow meter there to actually watch it run out of fuel or have a litre or two left and say, hang on, that is just as dangerous as just running the engine lean or over advanced just in general. Boost control plumbing and blow off valve plumbing. Just making sure, so that my tips there were probably based on things like seeing stuff where boost controllers are bleeding, like we call it measured air, but bleeding off manifold pressure readings off a map sensor or off a fuel pressure regulator or a blow-off valve or something like that, which in turn lets the valve hold open or bleeds boost pressure off the map sensor, one of the vital sensors of the engine management system.
Pretty common mistake. Yeah.
You see that a fair bit with cars that cruise through?
Yeah, definitely.
So definitely a handy one to look at.
My favourite one is where they've got an aftermarket boost controller and the boost line's teed in with the solenoid pressure supply. So you don't see much of a boost increase on the gauge, but actually it's very high.
I was doing a Z32 once, and one side of the engine was making 7 psi boost and the other was making 14 psi boost. It's difficult to tune like that.
Pretty easy to get to in a Z32. So a Z32 300ZX that's got plenty of space in the engine bay to get in there, right?
Yeah, exactly. So I let someone else get in there to try and work out where the hoses were melted or whatever was going on.
Admittedly, if I put those hoses on wrong, I probably would have sent it for a tune as well and thought, oh, I hope his hands are smaller than mine.
I would have just pulled the other hose off to match.
Checking the fuel pump wire is physically big enough to supply the current that the pump needs. Now, there's like some of these huge pumps that support amazing horsepower out of one pump, but they don't run for free. Like they need a heap of current. So the wire gauge that we need for these fuel pumps now is pretty amazing. The factory plugs that are getting used into the top hats of fuel, like over a fuel tank, stuff like that. I've seen some of them that have started melting because pumps are pulling 20 to 25 amps. Have you guys got like a rule of thumb of either, like, are you rewiring pumps or putting relays or bulkhead connectors and that sort of stuff?
That is a common issue. People are buying the big fuel pumps that pull a lot of current, melting wiring, and often it's usually the home guys, because anyone can change a fuel pump. So they get their uncle who's a mechanic or someone to come around, change the fuel pump for them. Uncle comes in, changes the fuel pump, puts a butt joiner there for the wiring, the new wiring to the old wiring, puts it all in, that's it. Car starts, idles, drives, makes it to the dyno, no problem. But again, we've got the flow gauge, so we know straight away once it goes on. But as for the wiring, we don't pull apart every single car to see. Some fuel pump wires beneath carpet, beneath trim, so it's, come in for a tune, we fill out the job card, get the info. If he hasn't said rewire it, then generally we'll put it on the dyno and go with it.
And this is the time that starts to chew up a heap of time for everybody. So simple things like what you're saying, that it's no one's fault really. If you have your local mechanic install a pump, odds are that local mechanic has never seen a fuel pump that is going to flow a genuine 450 kilowatts at the wheels. Like, they're putting in pumps for 50 kilowatts at the wheels, so any wire will do that job.
Exactly.
So you can kind of understand how this problem happens and why it chews up so much time when you're on the dyno, or worse, when it starts melting stuff and you don't make it to the dyno. So guys, have you got a couple of tips for us? How to get the best results on the dyno, get the car in, get it tuned, get it out with the least amount of fuss and the best result. What are some of your best tips, Andy?
Mitigate risks early. So what Adam was saying before about get the fuel flow sensor on there so you can know if you don't have that, if you get into power runs early, instead of tuning the whole steady state thing, then that allows you to find fuel delivery problems, ignition problems, that sort of thing straight away. Also having a checklist allows you to find obvious problems early as well. Even to the point where one tuner I know, he'll say, well, I don't know the car, so I'm going to look at it for 2 hours a day or whatever it needs first of all. If I find things wrong with it, I've got to fix them before it goes on the dyno. And he charges for that, rather than getting the car on the dyno and then having the awkward phone call with the customer afterwards.
I'm always a little bit superstitious, and I'm not so superstitious in life about anything, but the only one thing I am, and it's so dumb, I always tend to check everything, I do all my tests, I do everything, and then I just put chocks at the front, and I just start sort of loading it a bit, and I just suss out what's going on. And then once I get to sort of 50-ish kilowatts, or just a little bit, I'll put one strap on. And then if we go a bit further, I'll put a second strap on. And the only reason
Murphy's Law.
The only reason, it's dumb, it makes no sense, it does waste time. So you shouldn't be doing this. But if I put 2 straps on the back, 2 straps on the front, if everything's ready to rock and roll, I'll start it and it'll have a fuel leak, 100%. So I find that the least strapping I do, the further the car normally goes.
Well, because I've been mostly involved in diagnosing problems and not so much tuning, probably one thing that trips up a lot of tuners is when they encounter a problem, then they spend a lot of time fixing something that's not actually the problem. So if they see, the mixtures are going lean, even though the map's flat and that sort of thing, they'll go and change a pump straight away and then change a fuel reg straight away and that sort of thing, instead of discovering that, there's no pre-filter before the pump in the fuel cell and that sort of thing. So I'd say probably the most important thing is when you actually have a problem to diagnose and work out what are all the things it could be and eliminate them, rather than jumping to conclusions and spending money that isn't the right way to do it.
Don't start with a crankshaft problem.
Yeah, exactly, yeah.
What about when we're actually on the dyno and everything has gone right and it's making noise and it's all happening? Any magic when you're actually punching in the numbers?
Look, once you're past all the checklist and you're in the process of doing the actual mapping, main thing to keep an ear out on is knock, definitely. So always have some sort of knock phones on there and the earmuffs on to listen to the engine as you go. Also, fueling wise, make sure you start on the rich side rather than the lean side, and then pull it back. That would be the safer approach, and then opposite with the timing. So start on with low ignition timing and then feed it in as you go. So, but monitoring knock and making sure you don't go too lean.
So what I'm hearing today over and over again, the best practice is to not perform the worst practices, but the best practice really is do your apprenticeship. Learn exactly how every function in an ECU works. Learn how every device in an engine works, how fuel systems work, so that you're ready, you're prepared, so that at any trouble, you can point straight at something and say, that is the reason why this is happening. Adam Neish from Just Engine Management. Mate, thanks so much for spending some time with us today and going through your tuning hints and tips. Mate, we really appreciate it.
Thanks for having me, Scott.
Bloody good. Andy, thanks very much for the worlds of wisdom. You've been around forever and have seen so much stuff.
Thank you.
Mate, I keep looking at your shirt. I really hope that's coming out on camera, or maybe I don't, because that is our industry secret of just how everything works. So
I learnt everything from this shirt, Scott, so yeah.
As always, thanks very much for sticking with us till the end. My name's Scott, and we'll see you next time.